This video, we're going to graph cube root functions. So we're going to start with the parent function, just like we did with square roots, and then we'll talk about some patterns. So for a cube root function, we're looking for perfect cubes. So remember that with a cube root, I can use negative numbers. So I'm actually going to do two negative numbers, 0 and 2 positive. So if I think about negative 2 to the third power, that's negative 8. And so I want to use that because then the cube root of negative 8 is negative 2. So my first point is going to be negative 8, negative 2. Then I want to use negative 1 cubed, which is negative 1, because then the cube root of negative 1 is negative 1. So my second point is going to be negative 1, negative 1. In the middle, we want to use 0 cubed, because 0 is a perfect cube. So then the cube root of 0 is 0. So we're going to plot the point 0, 0. Then we want to do the positives of the same values we use. So we want to use positive 1 cubed. So positive 1, because the cube root of positive 1 is positive 1. So we're going to plot the point 1, 1. And then our last value is going to be positive 2 cubed, which is 8, because the cube root of 8 is positive 2. So we're going to plot the point 8, 2. So our graph for a cube root function looks like this. So since I can plug in negative numbers, I do have an arrow on both sides. So that's different from our square root function. So our square root function, remember, was only in quadrant 1 for the parent function. Because I can't plug in a negative, that gives me an imaginary answer. And imaginary values are not on this coordinate plane. So what's changing then is our domain and range. So notice that our domain is all real numbers, because I can plug in any value for x, because I can take the cube root of a negative number because of that odd index. If we look at the range, it doesn't look like it is now, but remember that as our x values get bigger or smaller, our y values are going to correspondingly get bigger or smaller, right? So the cube root of something really large is still going to be a larger number than the previous. So our range is all real numbers as well. So remember, if you prefer to write this as an interval, we can use the symbol for all real numbers, or we can write that it's going from negative infinity to positive infinity. So I can plug anything into a cube root and get an answer, which is why my domain isn't restricted, versus when we plugged into a square root, we couldn't plug in a negative, so our domain had to have a restriction in order to get a real value. If we look at this function, remember that we're looking at the y's. So as our x values get larger, so do the y values. So this function is also increasing. So let's use these strategies to find the graph of g of x. So we know, based on what we know about h and k and what we talked about, this is going to be a translation, but we're going to use this to kind of find some patterns so that we have some examples, and then we can use the patterns when we do example 2 using transformations. So if I am using the same strategy, remember my goal is to get the cube root of this same value, so the cube root of negative 8. So if I want this to be negative 8, what I'm going to do is identify what value plus 3 is going to give me negative 8, right? So what I'm thinking about in this step is what plus 3 is negative 8, because that's the first perfect cube that I use. And so based on that, that means that I'm going to plug in negative 11. Okay, so if I plug in negative 11, the cube root of negative 11 plus 3 is the cube root of negative 8, which is negative 2. So my first point for this is going to be at negative 11, negative 2. Then I want to know what number plus 3 is going to give us negative 1, because negative 1 is the next perfect cube. And so that means that I want to plug in negative 4. So negative 4 plus 3 is the cube root of -1, which is -1. So our next point is going to be -4, -1. Then we want to plug in a number that's going to give us 0. So what number plus 3 is 0? That number is going to be -3. And so -3 plus 3 is 0. So we want to find the cube root of 0, which is 0. So at -3, we're going to be at 0. And then for the next one, we want a positive 1. So we want to know what number plus 3 is going to give us 1. And so that number is going to be -2. So the cube root of -2 plus 3 is equivalent to the cube root of 1, which is 1. So our next point is going to be -2, positive 1. Finally, we need a number that's going to give us, positive 8. So what number plus 3 is going to give us 8? And so that number is going to be 5. So the last number we're going to plug into this function is 5. Plus 3 is 8. So the cube root of 8 is 2. So at 5, 2 is going to be our last point. And so we're going to draw our cube root shape, which again, if you remember thinking about what the cubic function looks like, a cubic graph looks like this. And so just like our square root was kind of a sideways version of a quadratic, we get that same effect with a cube root. And so notice that when our function translates, in this case, our function moved left 3, our domain doesn't change because our domain was all real numbers. So it's still going to be all real numbers even with the translation. And so our range is also still going to be all real numbers even with a translation. So no matter what we're doing, because of the nature of the graphs pointing in both directions, we're going to have a all real numbers domain and range no matter where our function lies based on our translations. Also notice that this function is increasing, right? As our x values get larger, our y values do as well. So this is an increasing function. So let's talk about patterns. So one thing to kind of think about and what you can look at is identifying a, h, and k in the problem. So this one, g of x, a is 1, h is -3, and there's no k, so k is 0. So what's happening here is that instead of at our first point being hk, notice our middle point is hk. And then the pattern is different because it's a cube root function, not a square root. So if I look at the difference going up versus going down, notice that for these, I'm subtracting 1, I'm adding 1. So that's the same as if I was graphing like a quadratic. But then if I go this way, to go from -4 to -11, I'm subtracting 7. To go from -2 to +5, I'm adding 7. And so that pattern is going to happen with our cubics because of the bigger growth that a cubic function has compared to a quadratic. So quadratic grows by that double every time. So we're adding 2 more each time. This increases a lot more quickly. For example, the next value would be 27. So if I think about that in terms of these, if I were plugging in -3 cubed or +3 cubed, we would get 27. So that's going to be an even bigger increase to go to the next value. So what we're going to look at is the y. So remember that in a quadratic, the y values increased by a, and this is happening here again. So the y value pattern stays the same, but the x value pattern changes. Another way to think about the pattern of the x values, and because of that, I'm going to erase kind of our side work right now, is that you can think about this as being the negative 11 as being negative 8 plus h, negative 1 plus h, 0 plus h, 1 plus h, and 8 plus h. So you can either remember this pattern where it goes 1 and 7 going up and going down. So you're subtracting going up, adding going down. Or you can just remember your 5 perfect cubes that we use and just add h to each of them. So you have 2 different options to determine those values in the table, other than just trying to write what number plus 3 makes negative 8.